Ha ha! Ladies and gentlemen, welcome, greetings. Greetings and welcome, both of them simultaneously, not a logical or separating those things. I don't want you to feel greeted or welcome. I'd like you to experience both of them. So, in this video, we're talking about multiplying matrices, and I'm just going to jump right into this. There's a couple constraints about multiplying matrices. We're just going to do an example. So if I'm multiplying two matrices, these are going to be 2 by 2 matrices. So here's a 2 by 2 matrix and a 2 by 2 matrix. And now there's some interesting things about multiplying matrices. Their sizes have to have some very particular settings. First of all, let's see, this is, remember, let's see, is it rows or columns first?
Rows.
Right? Roll call, right? Rows and then columns. So there's 2 rows by 2 columns. 2 rows by 2 columns. So what I want to point out is that the number of columns in my first matrix has to match the number of columns in the second matrix. Okay? So that's the first thing. Otherwise, it's impossible. You would just say no and run away. What?
No.
Oh, wicked bingo. What? Wow. Wow. Bingo, Waldo, whatever it is. I don't remember what it was we said, but I think it was bingo now that I remember. And the outer sizes, the row of the first matrix, all right, will be the rows of my answer matrix. And the columns of the second matrix end up being the columns of my answer matrix. All right, now this isn't a good example for that, I realize, because all of these 2's are the same. All right, we'll do some other size matrix multiplication in just a moment. I wanted to start with a simple one just to get things started, because figuring out the inside of the matrix is actually the hard part. All right, so my answer is going to be a 2 by 2. I'm going to draw it a little bit wide here. Actually, you might even want to leave off this. Whoa, muffler. You might even want to leave off this right-hand bracket until we finish writing the contents of this. But I know I'm going to have 4 elements within that matrix is what I'm expecting. So let's actually give some elements to these matrices. Let's say I've got 2, -1, 5, and 1 for my first matrix. And let's say for the next matrix I've got 0, and 4, and 3, and 5. Okay, so matrix multiplication is all about rows by columns, okay? So now to figure out my answer for my first row, first column element, what I'm going to do is multiply the first row by the first column, okay? So the row of this first matrix multiplied by the column of the second matrix, the intersection between those, I think you guys agree, is the first row, first column element of my answer, okay? So that's where that kind of comes from. So what do I get? I'd have 2 times 0 plus -1 times 3. Okay, so notice what I do. I shift these. I multiply the 2 by the 0, and then I shift right in the first matrix, and I shift down in the second matrix, and then I multiply -1 by 3. Okay, I realize this is crazy. It takes a little while for it to take root, so don't go crazy just yet. Actually, I just undid some stuff. All right, so the next one, to find my first row, second column element, I'm going to multiply, what do you think, the first row by the second column. Okay, so I'm going to have 2 times 4 plus -1 times 5. Whew, man, squeaking by on the room here. Okay, so a little bit weird, like I said, but it's working. It's working. Let's see. Next, to find my second row, first column, what do you think I'm going to multiply?
5 for
Second row and first column, exactly, yep. So I'm going to have, let's see, let me actually undo that. So 5 times 0 plus, and I always add these, 1 times 3. And for the last elements, looks like I'm looking for the element that will go in my second row, second column. So what do? I multiply my second row by my second column. So I'll have 5 times 4 plus 1 times 5. And then I can kind of square off this bracket. So I'm clearly not done here yet, because I have to simplify that. But the first thing I would do is figure out the size, so I know how many elements I'm looking for and where they're going to be, and then I do the multiplication. So let's see, let's simplify this. So 2 times 0 is 0, plus negative 3 is negative 3. Let's see, the next element, 2 times 4 is 8, plus a negative 5 is positive 3. 5 times 0 is 0, plus 3 is 3. Well, that's a lot of 3's showing up. 5 times 4 is 20, plus 1 times 5 is 5, so that's 25. So this is the answer to that matrix multiplication. Okay? It's a little bit abstract, I realize. And it just takes kind of practice for this to sink in. But that's the general outline for it. Okay? So let's try multiplying some other ones. Could I multiply this by, let's see, by this? Let's do negative 1, 1, 2, 4, and 3, negative 2. Let's see, what's the size of this matrix? 1 by 3. And what's the size of this matrix? 3 by 2, right? 3 rows, 2 columns. So, can I multiply these? Well, let's see, what's important? Do the inner numbers match? Yes, so that's good to go. So that means I can multiply them. And the size of my answer matrix is going to be the outer numbers. It's going to be a 1 by 2 matrix. So that's really weird to think about. Like, how do I multiply those two things and get a 1 by 2? Well, let's see what happens. All right, it's going to work. So 1 by 2 means it's going to have one row and then kind of, right, 2 elements within it. All right, I'm not even going to write this side until I figure out how that lands. So let's see. For my first row, first column, what am I going to multiply? The first row times the first column, right? Yeah, so let's see, 1 times negative 1 plus 2 times 2 plus 3 times 3. Man, I'm going to have a really hard time trying to fit this. Let's see if I can be sneaky. How clever am I? Oh, nope. Oh, let's see. Can I hit it all? I realize you guys... Whoa! I didn't want to scale it. I wanted to just shimmy it over here. I realize you guys don't have that advantage, but hopefully it's not a problem for you guys. Bam! And it's like nothing happened. You don't even know. So, to find my next element, what do? Yep, first row by second column, exactly. Let's see, I'm just cleaning up my schlop here. That's good enough. So, first row by second column, so let's multiply them. I'll use orange this time. So, first row by second column. And I would have, let's see, I'd have 1 times 1 plus 2 times 4 plus 3 times negative 2. Okay? And then I can close off my matrix. So let's simplify this. I'll actually even add another step in here of simplifying just to make things friendly. But you wouldn't have to write this step on your homework. So let's see, 1 times -1 is -1, plus 4 plus 9. Is that right? And then I'd have over here 1 plus 8 plus -6 or -6, I guess. So then let's simplify, and we get 3 plus 9 is 12, and 9 minus 6 is 3. And there's my answer. I know this is super weird, and you're probably starting to think at this moment like, why did mathematicians ever invent/discover this? Like, what's the point of this? And it will actually have extreme value to us later on. Extreme value. You'll be surprised. This will empower us to do many, many things. Better than we were ever able to do before. So, I think we've got time. Let's fit one more example in here. I feel like it's good to do that, just because it takes a while to get used to. Let's do a 2 by 4 multiplied by, let's see, if this is a 2 by 4, what does my next matrix have to have?
4.
It's got to be 4 by something, right? Let's see, let's make it a 4 by 1, I guess, just for sake of time. So hopefully you're getting used to the sizes of matrices and what they look like. So let's see. I can multiply these because we just made this problem right together so far, 4 by 4. And my answer matrix is going to be what size? 2 by 1, right? So was that the same size as our previous answer that we just had? No, that one was a 1 by 2. So a 2 by 1 is going to look, it's going to be tall and skinny. I'm not even going to fit it here. I'm going to actually do all my work down here just to, I'm not even going to try. So let's fill this matrix in. Let's see, let's do 10, 13, let's do 3, 13. Oh, I'm making some ugly numbers here. We'll have 4, 16. Oh boy. And let's do 10, 21. Whew. Those happen to be the birthdays of the members of my family. I just thought that would be fun. And then let's actually make this nicer for us. Let's do like 1 and 0 and -1 and 1, because I don't feel like multiplying 13s by stuff. A conveniently made problem. All right, so let's see. So I've got a 2 by 1 here. So let's figure out our first element. So let's see, for the first row, first column, I'm multiplying the first row by the first column. Blah, 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 blah. So that would be 10 times 1 plus 13 times 0 plus 3 times -1 plus 13 times 1. Whew. And for the next one, how do I find my second row first column element? Second row, right, by the first column. I realize this stuff looks so crazy, but it's okay. So notice as I'm multiplying, I'm shifting locations here, and I'm shifting locations down on this matrix when I pair up my multiplication pairs there. So I'll have 4 times 1 plus 16 times 0 plus 10 times -1 plus 21 times 1, right? And I realize this matrix looks like a wide matrix right now, but remember it's only one element. It's only got one column for its width, right? So it's a 2 by 1 because of these plus signs here. And one of the things I just want to point out, notice after doing this multiplication, notice that the second thing, right, that I'm multiplying by here happens to be this 1 twice. These are all zeros, these are all negative ones, and these are all ones. There are some kind of like semi-clever ways you can try to arrange this to pre-plan your multiplication if you wanted, but I kind of like thinking it out every time rather than figuring out a pattern to write this out. So let's see, let's figure out what this is. I might actually do this in portions again just for ease. So let's see, 10 times 1 is 10 plus 0, I love that, minus 3 plus 13. Let's see, the next one would be 4 times 1 is 4 plus 16 times 0 is 0, minus 10 plus 21. So our answer is going to be 10 plus 0 is 10, minus 3 is 7, plus 13 is 20. And then 4 plus 0 is 4, minus 10 is negative 6, plus 21 is 15. So there's my, I don't know, random weird birthday answer matrix, I guess. So yeah, so that's the idea for matrix multiplication. All right. So our answers can really be any size. I mean, I realized 2 of my answers had a dimension of 1, but I mean, if we had changed this number to a 3, we suddenly would have had a 2 by 3, right? So I just want to point out the answers can be any size, but you have to multiply very particular pairs of matrices in order to do this. Question, could I have, what if I wanted to multiply these in the other direction? Why can't I do it? Yeah, I would be trying to multiply a 4 by 1 and a 2 by 4, and then I'd be like, inner numbers don't match, right? So I'd be like, I can't do that. So it turns out matrix multiplication is not commutative. So A times B is a different thing than B times A. Peculiar. All right, so this is a very abstract operation. And we talked yesterday, you saw in that video, the TED Talk, that there's no such thing as division of matrices, which is true. We'll talk about that a little bit later. I mean, if multiplication is this crazy, just imagine what division looks like, right? Like, how would you even... Craziness, right? But I'll show you some cool tricks to accomplish simulated division later on. But anyways, so I think we're good. Bye-bye, Internet friends. I hope you were both greeted and welcomed.